Performance simulation and evaluation of systems and components is a typical application that can effectively be done in Flonex SE. In deep-level mining, ground and cooling water needs to be pumped to the surface. Due to the depth of these mines, high equipment and operating costs are inevitable. Knowledge of the equipment performance and condition is therefore necessary to reduce operational costs. Flonex allows simulation of complete mine water reticulation networks incorporating pump manufacturers' performance data and characteristics. In conjunction with performance data, Flonex can be used to point out equipment degradation and probable future failures. A typical mine water reticulation system example is the simulation of pump degradation due to particle wear. Due to the big pumping head, multi-stage centrifugal pumps are used. These pumps have wear rings in between stages to prevent recirculation of water around the impeller. Due to particles in the water, the wear rings wear, resulting in increased leak flow. Flonex can be used to simulate the pump including its leak flow, thus determining the derated performance of the pump. The picture shows a section through a multi-stage centrifugal pump which is used for pumping water. The wear rings for the impeller and shaft is shown in red as indicated by the black arrows. Due to wear, water recirculation occurs which is shown by the blue arrows. The manufacturer's performance curve for a single stage of the multi-stage centrifugal pump is shown. The red arrow indicates the pressure head versus flow rate characteristic for the 342 mm diameter impeller. Multiplying the pressure head by the number of stages determines the overall pump pressure head. A Flonex model of an underground pumping station is shown. The performance curve for the pumps is shown in the library. The manufacturer's pressure head versus flow rate data has been imported into this library. By selecting the Hydraulic Efficiency tab, the user can access the manufacturer's pump hydraulic efficiency data. Conceptually, the leak flow is modeled by means of recirculating flow from the pump outlet back to the pump inlet. In order to model the leak flow in Flonex, the pump is modeled with the pump component, incorporating the manufacturer's performance data. The leak flow is modeled with the rotating annulus component. Increasing the annular gap allows the leak flow to increase, thus effectively derating the pump performance. To demonstrate how the pump derating is incorporated into the Flonex model, select one of the pumps in the underground pumping station. Select the Pump Curve tab to open the Pump Curve library. Select the category, and then the pump's performance curve. The pump's operating speed is shown as 2980 revolutions per minute. Now select the rotating annulus component. The rotational speed of the annulus is the same as the operating speed of the pump since they are located on the same shaft. The inner radius, outer radius, as well as annulus length is shown, together simulating the pump's wear rings. The derated performance curve for the 342 mm diameter impeller is shown in red. This line simulates the pump's derated performance as a result of particle wear on the pump's wear rings. To conclude, Flonex can be used to simulate complete integrated water reticulation networks such as those used in the mining industry. Pump manufacturers' performance characteristics can be incorporated into the simulation, allowing simulation of the pumps. By means of derating the pumps, pump wear due to aging and suspended particles can be simulated.